Welcome! Today we'll solve a Bayesian inference problem involving posterior distributions for samples of size 2. Let's start with our given information. We have a sample space S consisting of 1 and 2, and a parameter space omega consisting of 1, 2, and 3. Here are our probability distributions for each parameter value. We have three different distributions, F1, F2, and F3. And here's our prior distribution pi of theta. The probabilities are 1/5, 2/5, and 2/5 for theta equals 1, 2, and 3 respectively. To find the posterior distributions, we'll use Bayes' theorem for a sample of size 2 with independent observations. Here's our formula. Let's calculate the posterior distribution for our first sample combination, 1, 1. For theta equals 1, we multiply 1/2 times 1/2 times 1/5. For theta equals 2, we multiply 1/3 times 1/3 times 2/5. And for theta equals 3, we multiply 3/4 times 3/4 times 2/5. After normalizing, we get our posterior probabilities for sample 1 about 0.157 for theta equals 1, 0.138 for theta equals 2, and 0.705 for theta equals 3. Let's visualize these probabilities. The height of each bar represents the posterior probability for that parameter value. In summary, we've calculated the posterior distribution for sample 1, 1. The same process would be followed for the other sample combinations, 1, 2, 2, 1, and 2, 2.